The world runs on minerals, hidden in your phone, your car, everywhere. But finding them is a real-life treasure hunt, starting with a map, not a shovel. Mining companies search for clues, using old maps, satellite images, and geological records. Geologists look for signs, odd soil colors, unique rock formations or fault lines, nature's breadcrumbs. Once a target area is found, the real adventure begins. Boots on the ground, far from the office. Prospecting teams hike deserts, jungles, and mountains, reading the story written in the rocks. They search for outcrops, bedrock breaking through the soil, looking for hints like quartz veins or green copper stains. Every rock and soil sample is carefully collected and sent to labs for analysis. It's slow, demanding work, piecing together a puzzle from tiny clues. The goal: build a picture of what's hidden beneath your feet. It's a high-tech, global game of hide and seek. Only the smartest, most persistent explorers succeed. The hunt for minerals is about patience, skill, and reading the land. Every observation matters. One clue could lead to a discovery. The adventure is just beginning, and the edge pieces of the puzzle are finally falling into place. With promising signs, the search narrows. Geophysical surveys use high-tech tools to scan underground, like giving the Earth an X-ray. Magnetic and electrical readings reveal hidden anomalies, possible mineral deposits. Teams lay out grids and collect systematic samples. This is geochemical sampling. They track chemical traces, following the trail back to its source. The closer you get, the stronger the signal. When a prime target is found, it's time for the moment of truth. Drilling. Drill rigs bore deep, pulling out rock cores, first glimpses of what's really below. Each core is logged, split, and sent to labs for assaying. Labs measure the exact mineral content, grams of gold per ton, for example. If the grades are high and the deposit is thick, you might have a discovery, but finding minerals is just the start. Now comes the challenge. Can you actually get them out? The treasure is real, but the journey is far from over. Discovery is just the beginning. Now you need to prove you have a real resource. More drilling creates a 3D model of the deposit, your underground blueprint. Engineers and geologists use this model to estimate how much valuable mineral is there. Next comes the scoping study. Is it mineable, and is it profitable? Will it be an open pit or an underground mine? What will it cost? Will it make money? If the numbers don't work, the project stops. At the same time, every mining project must secure permits and licenses. This includes community consultation and acceptance, landholder engagement, and all government permits. To support this approval process, a full suite of environmental baseline studies is required. These studies establish the conditions of the site before any disturbance takes place and cover noise, water, dust, air quality, and vibration. Engineers then complete predictive modeling to determine the level of noise and dust a future operation may produce, and the mitigation measures that will be required. The mine plan must show exactly how these risks will be controlled and reduced throughout the life of the operation. Carbon modeling is now mandatory in most jurisdictions. Companies must measure projected emissions and outline how they will be reduced or offset in line with current policy. In parallel, hydrology and water impact assessments are completed. Surface water models assess flood behavior and catchment impacts. Groundwater assessments evaluate the behavior of subsurface water systems to make sure the mine does not affect aquifers or sensitive basins that support nearby towns or agricultural regions. If there is any interaction with a major water system, the mining method and the overall project feasibility may need to change. Environmental approvals also require detailed botanical and ecological studies. Specialists identify flora and fauna that are endangered or critically endangered, and determine the controls and offsets that must be applied. These requirements influence the design of haul roads, facilities, and cleared areas. In addition, the project must address logistics and transport impacts, including truck movements, traffic management, noise, air quality, and compliance with regional planning rules. Power supply, water storage, and all supporting services must also meet the relevant environmental and operational standards. The final environmental and social assessment includes the full catalogue of local vegetation, seed banks, microfauna and microflora, along with clear plans for protection, rehabilitation, and long-term management. This ensures the project can comply with its environmental authority and meet community, regional, and government expectations. Environmental studies and community consultations are essential. Plans must show how you'll protect water, wildlife, and land. If the project passes these tests, it moves to a final feasibility study, the master plan. This document details every step, from mine design to closure. It's the key to raising the huge funds needed to build the mine. Only the best projects make it this far. With funding and permits, construction begins, often in remote wilderness. Roads, power lines, and worker camps are built from scratch. Heavy equipment arrives, and the processing plant takes shape. Mining starts, open pits are dug, or tunnels are blasted deep underground. It's a massive 24/7 operation, hundreds or thousands of people working in shifts. Miners, engineers, geologists, and technicians all play a part. Ore is drilled, blasted, hauled, and processed to extract valuable minerals. The mine plan is constantly updated as new data comes in. Safety and environmental monitoring are top priorities. Every day, tons of rock are moved, powering the world's industries. The cycle continues for years, sometimes decades, following the ore deeper underground. It's a high-stakes, high-pressure environment. Teamwork and focus are essential. Every mine has an end. When the ore runs out, the mission shifts to reclamation, restoring the land. The plan for closure was made before mining even began. Waste rock is reshaped, covered with saved topsoil, and slopes are stabilized. The goal: blend the site back into the landscape and kickstart nature's recovery. Buildings and equipment are dismantled, foundations buried, and contaminated soil cleaned. Open pits may become lakes. Tunnels are sealed. Water quality is monitored for years to ensure safety. The aim is to return the land to a useful state, wildlife habitat, forest, or grazing land. It won't be exactly as it was, but a thriving new ecosystem can emerge. Responsible closure is the final test of a mining company's character. From first map to final blade of grass, mining is a story of exploration, engineering, and endurance. When done right, it provides the materials we need, while respecting the wild places they come from.